What I highly recommend is, I know it seems silly, but I recommend you actually put those dots. Because what that's doing is that's telling you where it's going to break up. So it'll just kind of keep it organized for you.
Isn't there one between the...
No. Because this is the word of, it's like f of x, that's not a multiple. It's just a notation. Okay, so I'm going to break all of those multiplications and they're going to turn into additions, right? Right, let's do that. Equals, and you're going to need that equal sign because what you're doing is you are simplifying an expression. You're not solving, so you're not solving for x at all. You're simplifying an expression. So this is going to become log base 4 of 16, and then that multiplication is going to become what?
4.
Plus what? Log. The log is going to be needed again. This multiplication, I'm taking that 16 and that x cubed and turn them into a plus with 2 separate logs. The log has to go all the way through. And then there's going to be another plus log base 4 of what?
Y to the 4th.
Y to the 4th. And then there's going to be what?
Log base 4.
Plus.
Z.
Plus. Perfect. And then again, the log base 4 of z. You got it. Does that make sense to you guys? All those multiplication turns into plus? What's another thing that I know? What's another property that I have about logarithms? Hint. Look at the third one down.
See, that's what I thought, but...
Oh, the base.
I thought that x...
This exponent just came out front, right?
Gotcha.
So do you see when I have exponents, it's just going to come out front? Does that make sense? Let me maybe circle it. That could help you. One of the rules of logarithms, one of the properties of logarithms, is this exponent can come out front. So that means the same thing with all of those exponents can come out front. And that one doesn't have one. Does that make sense to you guys? Just following those? Do you believe me on that property?
When you mean that, you mean you can write it that way?
Yeah, you can rewrite it as 3 times log base 4 instead of x to the 3rd. Let me show you. Let me finish this one. Let me rewrite it so you guys can see. First of all, what's log base 4 of 16? Q. I'm just simplifying each one separately. And then I have a plus. Now this 3 can come out front. Now it's log base 4 of just x. See how I took that 3 and brought it out front and like literally picked it up and moved it? Does that make sense? And then this will be plus what?
1. Oh.
4, because this exponent I'm bringing down. Log base 4 of y now. Plus, can this one simplify? Yeah, time. And I'm going to do, let's do 5x to the 8, y to the 3rd, all over z squared, and then I'll do b 7. I just kind of make that up. Same idea. I want you to rewrite as a sum/difference of multiple logarithms. So break it up. So I'm going to do this same problem twice. I'm going to do the long way, and then I'm going to show you the shortcut. You guys may or may not like the shortcut. I do, but I'll show you both. So you have both. So what's the first thing I got to do? First of all, I need to realize that there is a division in here, right? So that division is going to turn into what? Subtraction. That's that second property that we have. So this division will turn into a subtraction. So let's do that first. This will become ln of the entire top minus ln of the entire bottom. Notice that my ln followed through. Can you guys see that okay? Ln of the top minus ln of the bottom, because that division turned into subtraction. And then for each one separately, you can now take those multiplications and turn them into additions, right? This is the 5 times, this is the next times, and so on. So let's do that. Equals. This is going to become ln of 5, and then what? Plus ln of x to the 8, plus ln of y cubed, right? You guys see that okay? Now here's the trick, and here's the part that a lot of people forget, so pay close attention. This minus is a part of this entire ln. So what you really are going to have is one big parenthesis. Because that minus is in front of the whole thing. Because later on, you will have to distribute. Pay close attention. See how that's a multiplication and it'll turn into addition? So this will become ln of z squared plus ln of b to the 7? Can you guys see how I put a big, huge parenthesis around that subtraction thing? Because this minus will then have to distribute. Okay, so let's keep going. ln of 5 plus, how could this guy simplify? 8, then what? Plus what? Can you guys see where that 8 and 3 are coming from? This exponent just coming down up front? Cool, right? Okay, now can you see that that negative will have to distribute? So, I'm going to do them at the same time. Bring that number down, that's a 2. Distribute that negative, makes it a negative 2. ln of z. You guys see what I did there? I brought this 2 down, that's a 2. Distribute that negative, so that's a negative 2. Bring this 7 down, so that's a 7. Distribute that negative, so it's a negative 7.
It doesn't seem difficult, but you have to be very careful with your details.
Here's the thing. Almost everybody forgets that minus. It's fact. Every time I'm not trying to tell you this to tell you that you will miss it. I'm just letting you know that that's where oftentimes that mistake is. So pay attention to that negative. Now, what I think will really help with that negative issue is if I show you the shortcut. Are you guys okay with me showing you a shortcut?
Sure.
You have no choice. I'm going to show it to you anyway. May run out of room, but I'm just writing it small. Okay, so here's what I'm going to teach you. We can do from the question straight to the answer, showing no work whatsoever.
What?
It's kind of cool, right? You guys already knew that division became subtraction, right? So that means that everything on top is positive, everything on bottom is negative. All the exponents can drop down. Let's go back and look at this property for a second. M was on top, right? M had the positive. N was on bottom. N had the negative. Everything on top is a positive, everything on bottom is a negative.
So then that subtraction sign is really the division sign.
It's a subtraction sign, but it's how you remember
Yeah,
action.
yeah.
I don't want to say a subtraction sign
Right.
because you're recording me and that's wrong.
Oh, that's right.
So it's the property that turns it. So on top, you take everything on top and you break it up, all with a plus. And then on bottom, all has a minus. And then you're done. So on top, I got the 5, so this is ln of 5 plus, I bring the exponent down, ln of x plus, I bring the exponent down, ln of y. That was everything on top is positive, all the exponents came down, right? Now everything on bottom is negative, all the exponents come down. So minus 2 ln z minus 7.
That is easier.
That's easier, yes? This is the first semester I'm doing this, actually. I used to make my students do the long way every time. But now I'm going to let you do it this way. I won't mark you wrong. I'm going to trust you. If you're not confident in this way, then maybe do it the long way. But see how that's a little easier? And we got the same answer, right? It's easy, right? But we do know that we can bring exponents down. So we have to make sure we have exponents. So I'm going to first, bear with me, I'm going to take that square root and turn it into an exponent. What exponent will it get? You guys remember that the square root has an exponent of 1/2? So I can rewrite this as log of 100 x to the 1/2, y to the 1/2, z to the 4th, x to the 3rd.
Why wouldn't it be xy?
It is. It's xy to the 1/2. Both of them get it. Because it's multiplied. If it's addition, it wouldn't, but because it's multiplied, yeah, they both get it. You guys see that okay? What I did? Now can I skip straight to the answer? Everything on top is positive, everything on bottom is going to be negative. So this will become log of 100 plus, then what? Then what? Somebody else. Then what? Somebody else. Minus. Why is it minus now? So minus what? Then what? See, that's not too bad, right? I really feel like I think me teaching the shortcut is really going to help you guys. I'll put it away. But really, I'm not quite done. What am I missing? Log of 100 can simplify. If it can simplify, do so. What is log of 100?
10.
Because the base here is 10, and 10 squared is 100, so this would be 2. Right? If you write something, let me just finish real quick. If you write something like this and leave it, that's just as bad as writing this. You got to reduce your fraction. You can't leave it like this. You got to rewrite that as 2. You see what I'm saying? It's just as bad as not reducing the fraction. Okay, yeah, there was a question?
Yeah, can we combine the log x and log x?
I like your thinking. She said, can we combine this log x with this log x? Are they like terms now?
Yeah.
Yeah, absolutely. So I have 1/2 minus 3. So what is 1/2 minus 3? Negative 5/2, right? So this became 2. Now I still have the 1/2 log y and the negative 4 log z, but now I have negative 5/2 log x. Thank you very much. Well done. You guys see that? Now we're just going to do the same thing, only working backwards. So we are going to rewrite these as a single logarithm. So work our ways backwards. What could I possibly do? The plus is on top, the minus is on bottom, right? We're working backwards, right? That's one thing to think about, absolutely, right? The addition turned into multiplication.
And
The
then
subtraction turned into division, and then go ahead.
no, it's the coefficient up as an exponent.
Put that coefficient up as an exponent. Well said, perfect. So let's go ahead and do that. And I'll help you out right now. There's really not, you could skip a whole lot of steps if you wanted to. For these ones, I'm going to try not to because it can get kind of confusing. I'm going to first take all those coefficients and bring them up as exponents. Okay, that's going to be the first thing I do. And then that's going to become ln of 5x plus ln of x cubed minus ln of y squared. You guys see that okay? All I did is I took this 3 and put it up as an exponent.
And you put it back.
Put it back, because I'm working backwards. This is telling me to work backwards.
And you just put the
Yeah, so now we're going to do that. Addition is going to turn into multiplication, subtraction is going to turn into division. And here's something that's really important for these ones. You really, really have to work left to right. Okay? You can't do first this guy and then this guy. You got to be careful. So there's sometimes it works, but it doesn't always work. So you just got to be careful. Always work left to right. You guys just do me a favor for these ones and always work left to right. So I'm gonna take it slow. Now I understand some of you guys could skip some steps, but we gotta start off not skipping. Left to right. The first thing I see is an addition, right? What's that going to become?
Subtraction.
Multiplication. Addition becomes multiplication. So this will become ln of, now I have 5x times x cubed. See those two ln's combined into one ln, the multiplication? And now this subtraction will become what?
A positive? An addition?
Division.
Oh, division.
Yes, the subtraction turns into division. So this will become ln of, what's 5x times x cubed?
5x to the 4.
And then this subtraction becomes a division.
Y squared.
And I understand, like I said, I understand if you can skip some steps, so I'm going to try not to. Just for these ones. Ta-da! Questions on that? Go ahead. Never mind. Okay. Let me do another one. So let's do log base 3 of x minus 3 log base 3 of x minus 2 plus 4 log base 3 of y. Okay, let's do the same thing. We're working backwards. What's the first thing I should do? Bring those coefficients up front as, at the top as exponents. So this coefficient could go up and this coefficient could go up. So let me show you what that's going to look like. So this is still just a log base 3 of x. That's kind of a boring one. Leave that minus alone for now. We'll come back to it. We will, I promise. Just take the 3 out. And this will become now a log base 3. And here's what's important. It's the entire x minus 2 to the power of 3. Okay? You don't do each one separately. You don't do just one of them. It's the whole thing. Anytime you have a plus or minus inside a log, you can't mess with them. The plus or minus is outside the log is what you can combine. The plus or minus inside a log, can't mess with them. Has to stay as it is. And then I have now plus log base 3 of y to the 4th. And now I'm going to work left to right. Subtraction will become division. Addition will become multiplication. You guys okay with this so far? Equals left to right. It's important. Don't do this one first just because you like plus signs first. You'll get the wrong answer. Do it left to right. So this subtraction is going to become what? You guys see how that subtraction turned into a division? No. This subtraction, I took this first one and put it on top. The second one, put it on bottom. The 2 logs turned into 1 log. Yeah.
How about if we combine all positive together?
Sure, you can. Yeah, you can do that. Now do I see the addition is what I have left? The addition is going to turn into what?
Multiplication.
So this is going to be log base 3 of this whole thing times that whole thing.
Oh, okay, I got that. Got it.
If you want to make that one fraction, this is like a y to the 4th over 1, and you can combine it that way if you really wanted to. And that would become x y to the 4th over the x minus 2 to the cube. I would accept either one. Any questions so far? All right, how are we doing with logs so far? You guys getting sick of the logs?
Sort of.
A little bit? I'm just going to do this one problem, and then we can take our break, I promise. We're going to do this problem. Still using the same properties, only I'm using them in a different manner. I'm using them with only numbers now, not any variables. I've got only numbers up here. Okay? And here's the thing. I am given 3 separate values. I don't know what the base is. They've just called it A for something that I don't know what that base is. That's okay. But I do know that log base A of 2 is this number. So I know the values of these 3 different logs. And I want to find the value of log base A of 98. Here's the problem. I only know log base A of 11, 7, and 2. How am I going to find 98? Well, you have to break up 98, and so they somehow can look like a 7, 11, and a 2.
Using like multiplication.
Absolutely, using any of those operations that you need. Really, the best way to do it is just break it up like this. Factor tree. 2 times what? 49. Do you guys agree that 2 times 49 is 98? Good. How do I break up 49? 7 times 7, right? So that means, and 7 can't be broken up any further, so that's my top. That means I could rewrite this, and I'll do this, actually, I could rewrite this now as log base A of 2 times 7 times 7, right? Can I just write that as 7 squared? And now what I'm doing is I'm taking this, and I'm going to use those properties that we did before about breaking up your logarithm. Okay? And so those properties are, I can simplify this. This multiplication is going to turn into a what? Addition. So 2 plus log base A of 7 squared, right? But what about this exponent? What can happen to this exponent? You guys see that? Because what I've now done is log base A of 2, I know. Log base A of 7, I know. So now I just can plug in the numbers. So this becomes now 0.813 plus 2 times 1.204. Can you guys see that okay? Are there questions there? Anybody want to plug that in for me and tell me what the answer was? Simplify that. This plus 2 times that. You could do this without your calculator if you had enough patience and time, right?
3.2 something.
I won't be exact.
Exact. I don't know.
Oh, all right.
Come on. I saw you guys plug it into your calculator. What is it?